All right. Last couple of notes about the capsid and how we're going to form it. So, the capsid is made up of 4 proteins, VP1, 2, 3, and 4. During protein synthesis, we're just going to make that one long polyprotein, and then everywhere that you see a little purple diamond, that's a piece that's going to be cut apart by the 3C protease, which is the main protease. And so you can see it cuts 3A and 3B and 3C and 3D, and it separates between 2C and 3, and between 2B and 2C, and between 2A and 2B. Isn't that fantastic? It also separates between VP3 and 1, and between VP0 and VP3. So those are all main protease cuts by the 3C protease. Yes. The 2A protease cuts one time. It cuts right here between region 1 and region 2, so it's going to cut between VP1 and 2A protein. So it cuts itself off. Yeah, a little self-motivated protein. Each of the capsid proteins, so they're actually going to be produced like this, and there's going to be, there is a little leader protein on some of these, but don't worry about that. VP0 is going to be cleaved later, and you see there's a little question mark there, which is still accurate. We're not sure which protease cleaves it. It appears to be one of the host proteases that cleaves it, and we're not sure which one, so that's fine. It's not a thing that you can write in the test answer unless you can dig up, a new paper I haven't seen, in which case, good for you. Good for you. Oh my gosh, I'll be excited to read that. Anyway, VP0 is going to get cleaved later into VP2 and VP4. So 2 plus 4 equals 0. Virus math. Viruses are the best at everything, aren't they? For sure, yeah. The 3 proteins, VP1, VP2, and VP3, are all beta jelly roll folds. And so this is showing you what that's like. There's sort of 3 strands here, 3 strands on the bottom, 4 strands on this side. Just imagine those sort of sandwiched together with an alpha helix connecting the two, and that's a beta jelly roll. And so this has the structure VP2 and VP3 does, and VP1 does. VP1 also has some extra stuff, which will do receptor binding and things like that. But fundamentally, they are all beta jelly roll proteins. VP4 is not a beta jelly roll protein. It's just a little tiny bit of stuff, and it's going to get myristylated. So here's the site of myristylation right there on the end terminus of VP4, and that is going to be necessary for the entry process. The pocket factor is right here. So this is a fatty acid of some sort, maybe generated by that phospholipase that seems to be involved in virus entry. We are not sure, but that pocket factor is this little fatty acid molecule, and that's going to bind into the pocket of VP1. There's a hydrophobic pocket there, so there you go. That's all the stuff we already talked about on entry. And so now we just need to build this thing. So to build it, we start by translating the polyprotein, and then we're going to cleave it. So we're going to have the main protease, 3C, is going to cut at the end of VP1 and VP3, and then the 2A protease is going to cut between VP1 and the 2A protease and itself. These will then come together. So we're actually going to assemble VP0, 1, and 3. So VP4 does not get to be free yet. We assemble it with 0, 1, 3. And remember that 0 is both 2 and 4 together. They're just stuck. So there we go. 0, 1, 3. And so we're going to bring those together, and that's going to make a little protomer with 0, 1, and 3. Then we're going to put 5 protomers together, and we're going to make a pentamer. And there we go. And once we've got our pentamers, that's still VP0, 1, and 3. We're going to put 12 pentamers together, and we're going to make ourselves a procapsid. And so either the RNA is loaded in before we generate the capsid, or the capsid is formed first and then the RNA is loaded in. That's another at least open question for the moment. I don't believe that has been adequately solved. Anyway, now we have a provirion, and this is still inside the cell. So it's got RNA, it's got VP1 and VP3, and it's got 5 copies of those. So that's a pentamer, or a penton, they sometimes call it. And it's got 12 sets of those 5, so it's got 60 copies of everything in there. 60 VP1, 60 VP3, and 60 VP0. VP0 will then be cleaved by an as yet unknown host protease. That then becomes the mature form of the virus, which is now able to infect. So while it's immature, we think it's probably not infectious, or the infectivity is limited, in part because VP4 is stuck to VP2. And if it's stuck there, it can't really come loose and go and form a pore along with VP1 in the membrane, can it? So there you go. That's the idea. And then once that is formed, it basically just waits for the cell to rupture. They do not have a good way of getting out of the cell without the cell dying. Coronaviruses can infect the cell, and coronaviruses can establish persistent infections that'll go on for years inside of a mouse or maybe a person. In contrast, picornaviruses are a 100% kill virus. They always destroy the cell that they are in, and that's the only way that they get out. Ruthless, terrible, just awful little viruses. Picornaviruses, but kind of neat the way they work and the way they kind of defy the odds and assemble themselves and kind of do everything, even though they're so tiny. Yeah, so fragile, vulnerable. Anyway, enough anthropomorphizing. I hope you enjoyed this part of assembly of picornaviruses, and I hope you can use it in the test question.